So right now in this part of the video, I am going to try and find out the coefficient of static friction between the green surface and this wooden surface by just using an inclined plane. And right now the angle is at 0 degree of the inclined plane. At first, as you can see, there is a new attachment over here which is a protractor, which helps me determine at what angle exactly does this body start to fall. Like as you can see, I am slowly lifting this board. So as you can see right now, this black pointer helps me determine at what angle is this board with the horizontal axis. So right now I am going to try and find out like what are the different forces are acting on this body when this board is lifted upwards. So right now let's first do some geometry. Over here, let's take this a certain angle theta. So if we increase this line downwards, this is 90 degree, as this is a vertical axis and this is horizontal axis. And since this is 90, this means this angle is 90 minus theta. Since this is 90 minus theta, these two angles are vertically opposite. So this angle is 90 minus theta and this angle is 90 degree. So at last we find out that this angle is theta. So as we know, the weight of a body always acts from the center of mass of that given body. So the weight of this body is currently acting in this direction, and the normal reaction actually acts in the upward direction of the surface on which the body is kept. So the normal reaction is acting in this direction. Since like the weight of the body and the normal reaction are in totally different axes, it means that N is not equal to mg for this current situation. So we have to take components of mg right now. One is a vertical component, another is a horizontal component. The vertical component is equal to mg cos theta, while the horizontal component is equal to mg sin theta. Since there is no vertical movement with respect to this inclined plane contact field, so it is that n is equal to mg cos theta. And since as we slowly move this inclined plane, like the angle is slowly increasing, it means that this body is also wanting to go downwards. But friction opposes relative motion, so friction in turn is acting in this direction. And as we know, we must take the situation that when the body just starts moving, that means that then only we can find out the coefficient of static friction. So when the body just starts moving, the friction will be equal to maximum static friction force, and mg sin theta is acting in this direction. So we can write that Fs max is equal to mg sin theta. We also know that Fs max is equal to mu s into L, which in turn is equal to mu s into mg cos theta. So by replacing Fs max's value over here, we find out that the equation is mu s into mg cos theta is equal to mg sin theta. mg gets striked off from both sides, so at the end we get that mu s is equal to sin theta by cos theta. And from trigonometry we know that sin theta by cos theta is equal to tan theta, so mu s becomes tan theta. And actually the angle at which the body starts moving is also known as angle of repose. So we can take that this angle is theta r. So mu s at the end becomes tangent of angle of repose. So in this experiment, what we will do is that we will slowly increase the angle between this board and the horizontal axis, and at the angle at which the body just starts moving, we have to just take tangent of that angle to find out the coefficient of static friction. So right now let me start doing the experiment. Right now the body still has not started moving. It has still not started moving. Yes, it has just started moving at approximately 35 degrees. So let me just set it up. Okay, so the coefficient of static friction between the green surface and this wooden board is equal to tan of 35 degrees. Which is ultimately approximately 0.7. So from the earlier experiment, we found out that the coefficient of static friction between this green surface and this wooden board is 0.7, and from doing that mu is equal to tan theta, we also found that it is 0.7. So it means that this is correct and that earlier experiment was also correct. So I hope you like this part. Now let's get on to the next part.